I think many of you have heard the myth about the falling icicle can kill you if it hits you right. I believe Mythbusters even did an episode on it. And we can talk a little bit about the math behind it and why. So we're going to talk about the conservation of mechanical energy. And whenever we want to do this, we have to ignore friction in any form because that would take away some of the mechanical energy and turn it into thermal energy usually. So these will always say ignore air resistance or ignore friction. And the general idea of the conservation of energy is just the same as the conservation of momentum. If we write it out in equation form, the kinetic energy plus the potential energy at the beginning is equal to the kinetic energy plus the potential energy at the end for any system. So in this case, we have an icicle that's falling from a roof. Well, when it's up on the roof, its kinetic energy is 0 because it's not moving. It just has potential energy. And when it falls to the ground, its potential energy is 0. All it has is kinetic. So we know that the initial potential energy equals the final kinetic energy. It's theoretically all conserved. So our mass is 14.8 kilograms, and our height is 8 meters. If our potential energy is mgh, we would have 14.5 kilograms times 9.8 meters per second squared times 8 meters. And we would calculate that our potential energy is 1137 joules, which means that our kinetic energy is equal to 1137 joules. So if we think about significant figures, we can round that to 1100 joules, and that's our answer to the first question. We can also find how fast it's moving by using the same value. Ke equals 1/2 mv squared. So 1100 joules equals 1/2 times the mass. That's a gigantic icicle, times v squared. We get that our v squared is equal to 152. And when we take the square root of that, we get that our velocity is equal to 12 meters per second.